Now please welcome Dr. Johannes Bohnet, CEO and founder of Seerene.
So, a second time, welcome everyone to the conference. I would also like to speak about AI, specifically AI in the context of software production, software development, software production. And I will go a little bit into the past, then into today, and then into tomorrow, but not the far future, but let's say like 5 years. 3 to 5 years, similar to what Jürgen said. And we as Seerene, we have built a platform with which you can monitor, with which you can look inside the activity, what's happening in big and large software development organizations. And we do this for many kind of customers from all kind of domains, industries, banking, insurances, automotive, etc. So that's why we already now have a very good view, a look inside of what's happening today. And we also do that for companies who start to use generative AI tools for code production. And that's why we can quantitatively see the impact in terms of productivity boost, the impact in terms of risk. I will speak also about risk because this is not straightforward. I put it into the title, right? It's not just the happy path you enter if developers use generative AI tools. There's also risk involved. And yes, and finally, I will say that again at the end. Currently we are building up a benchmark about productivity, about in general software production excellence in organizations. And if you would like to participate, you're welcome, and please contact me afterwards. So, starting with the past. I didn't. By the way, I will use these old metaphor of building a house. Right? This is a very old metaphor to try to explain what building software is. You will see the metaphor breaks at some point, but if you go back into the past, it works, right? I didn't go back into the past where houses were built of earth and mud. I started, let's say, where high-level programming languages came up, like C, C++, which means from a timing perspective, yesterday here in that picture means until 2005, 2010. This is the time dimension. And what happens there is that software production, producing code is a largely manual thing. But it already makes use of building blocks, reusable building blocks, bricks. Right? For example, if you're programming in C, you wouldn't write every bit like string comparison. In assembler, you would have done that, right? But in C, not anymore. So you already make use of reusing parts. And if you look at what is needed back then to do programming, to produce software, primarily it was about knowledge about specific programming languages, data structures, algorithms. Back then in university, this was the main topics, data structure and algorithms. Today, it's irrelevant if you know how a quicksort algorithm works. Why? Because today, which means from 2010 until now, it's much more about knowledge about prefabricated building blocks, which is the frameworks, the libraries. And Java was one of the main driver for that. So if you as an organization wanted to hire Java developers, it was not about the language. It was about the frameworks that the developer knows what prefabricated building block should be taken from the Java library, right? And if you nowadays look at job descriptions, for example, it's not saying we are looking for a developer who can develop in JavaScript. It's more like Angular.js, Node.js. The JS is JavaScript, right? So, but it's more specifically knowledge about frameworks. And for example, building up an internet communication stack, TCP, it's super easy. It's just 3 lines of code with the right framework in the backend. You don't have to do it manually like before. So in the house metaphor, it is still today more or less this way how to build a house, not brick by brick, stone by stone, but knowing what kind of prefabricated building block is the best thing. Tomorrow and starting already today. So we are already in the tomorrow part. It's, what has happened? All the knowledge of what kind of framework is the right framework, what kind of building block in the framework should I take to build this house fundamentals. This is publicly available. Right? This is, and because of open source primarily. Open source started in the, also 2005, 2010, the Java framework went open source. Everything, the knowledge about this went open source. So this plethora, this multitude of opportunities that you can have as prefabricated building blocks, this is publicly accessible and has been learned recently. With the large language models, ChatGPT and all these, they know about this. So it's not the special knowledge you need anymore in your brain as a developer, because you can just specify, I want to have a web server or website with a shop system in it, and the machine already knows what's the best ingredients for this, and it also prints the like a 3D printer, it prints the glue code to bring this together, right? So if you look at this, it's more like software production is more like knowing how to speak with a machine, how to specify, how to talk with these AI-based systems. So at first sight, it looks like there's no need for people anymore who understand, who know anything about code because the machine does it. At first sight. Why? Because the house metaphor breaks. Software development, this is not the core of software development, building a house. The core of software development is coming after that. Why? Because building a house is clear from a requirements perspective. It addresses a commodity, a mass problem. There are many people living in houses, right? That's why it's already clear, upfront clear, what people would expect to do with a house, right? It has buildings, there's some staircase, etc. And for some of these software systems, it's also the case. If you want to have a static website for your company, it's more or less clear what you need. If you want to build a web shop for small business, it's more or less clear what's been needed from a requirements perspective, some paying things, some putting your products on it, some editing of this. So the requirements world for these kind of software systems is clear upfront. That's why my prediction, or what we already see, is for these kind of software systems, you actually do not need programmers anymore. Actually, before large language models, this was already the case because there were agencies, there were system integrators who did that job for you, and they ramped up that system and built the website, and that's it. SAP is somewhere here. I put HR software for small, medium-sized companies. This is also clear. It's like if you have employees, they want to have vacation, you need to track this, etc. So requirements clear. SAP is more difficult because it's like the foundation is clear, but afterwards comes a lot of adaptations. I personally think that AI will drastically reduce any kind of costs that you currently pay to third-party system integrators, because this can be largely, this manual or this human being thinking processes and the doing part can will largely be replaced by speaking with a chatbot and doing the adaptations for you, which means the prices will down. Maybe you won't do it by yourself, but the system integrators will have to reduce prices for that, because it's not brain knowledge anymore needed for this. So this is house metaphor until here. For software, for problems in the world, mass problems which have already been solved so many times, so that the users know what they want, what they expect from the software. So things that can be specified upfront. Most software systems, however, start from here. So this is now where software development and software production actually begins. Building the first house is trivial. Now comes the tricky part. Why? Because most software systems are very unique and specific from a requirements point of view. For example, if you have a specific business process that only you and your organization have and you want to support, let it be recently building a digital twin of the physical things you produce. You don't know actually the use cases yet, what you want to achieve with that kind of software in your organization. It's a learning process. So most software systems evolve, and because the users cannot tell you right now what they want to do with the software. They learn that by using. This is the case for specific IT systems, like internal systems supporting the business. This is definitely the case for if you're a company who builds products, physical products. The innovative part today is mostly the software embedded in the hardware. And this is innovation, and innovation means new, so there's nothing new means you have to build it, right? And the software itself, if the software itself is the product, it's the software is the innovation. So, and by the way, maybe you've noticed this if you look at organizations, how they manage software production worldwide and across all industries. The delivery models of software organizations have changed from waterfall to agile, exactly because of that. Because it's not clear upfront what shall be built. Waterfall means you have a complete specification, requirements are clear, then you build it, and then you ship it. And what happened in the past, back then, it happens that, yes, the software was delivered after 1 year, 2 years. It was perfect, exactly like the requirements was, but the users said, but that's not what we need, that's not what we wanted. The world has changed, we need to adapt, and maybe this is a misinterpretation. The requirements was not, we did a mistake on the requirement side. So everyone changed to agile because of that. So today, it's finding out requirements on the way. By the way, I need to look at, see the time. So if we go back to the house metaphor, then this evolvement, how a house evolves, is the typical case. right? Starting with a family house, and over time, it evolves to some office building, and the original part is upside down somewhere there. And it starts with simple things, like family house, and then the couple says, oh, let's switch the bedroom and the bathroom, which has a strong impact on the plumbing, on the water pipes, right, on the architecture, already just a small changing rooms things. And so it's software development is more about continuously reshaping the software. And it has this strong impact on architecture, on the purpose, on the function of the software. And this is why generative AI tools is, jumping back, the specifiable problems can already be solved without human interactions, like Jürgen said, right? But generative AI tools for, let's say, the more complex part, the majority of the software systems needs to support developers or the developing organizations in this incremental step. And what is software development in a nutshell? It's requirements, specifications, it's today and also in future. It's requirements, it's breaking down into some work packages, it's then doing the implementation, but on an existing code basis. All right? So here are the many developers who are constantly reshaping the code bases. Then it goes via quality assurance to some executables, to some living software, and then the users can experience this. And the next iteration comes, and then they say, OK, switching bedroom, bathroom, or having this button here or this functionality there. Sometimes also things happen like building a house, and then it turns out that asbestos is not the best material to build a house of, and they need to change. So there are also more changes coming from the context, from a technology perspective or other kind of stuff. So, but generally, user will ask for changes about this. And generative AI now hooks in here. Today already, GitHub Copilot, for example, to name just one of these helping tools. Before, you would do all this with a screwdriver. Now you have some, actually I did this with ChatGPT, to have some kind of screwing robot. So you're much faster today already. And you don't, but very important aspect here, it's, before I said Gen AI-based code production, here I reduced the term and say Gen AI-assisted code production. So it's today, you need the human brains to check the proposals being given to you by these Gen AI tools. There's another limitation today, maybe in 3 years, not so much anymore. This is the context window. So the large language models learn a lot about world knowledge. They have not learned anything about your software system yet. So they have very limited knowledge only about your software system. It comes into the large language model via this context window, right? And retrieval augmented generation is the term for that. It picks just very specific part of your software system together with your question, iterate over that data structure and print all the names of the person data structure. This is going into the large language model, and then a snippet of code is produced. This is what this screwing robot does today. And because the context window is somehow small, the proposal is not always the best one. So you need more skills today if you are working with this instead of the screwdriver. So developers need from the knowledge, what they need to know, they need to have more architectural maturity to assess what's being produced. Like it's more senior level that you need here to work with that. Question now is always interesting also from management level, how much productivity can we gain if we're using these kind of tools, if we are paying these licenses to AWS, Microsoft, whatever, having these smarter tools, giving it to the developers. There are studies, but if you look at today's studies, there's a strong bias in it. For example, you can ask me later for studies, but there are multiple studies from the vendors itself, and they claim faster task completion, up to 10 times more faster, less knowledge needed to complete the task. Also, the junior developers can do it before you need the high-skilled senior developers. The bias is the tasks in these studies are more like hackathon tasks, which means sharply specified small problems. So it's this printing a house kind of task. And that's why, and we also, as I said, we have customers, big organizations who already start giving these, for example, GitHub Copilot into the hands of the developers. And they also run systematic studies internally. And it turns out, if it's the case, if it's more this prototyping way of building software, in the data engineering field, it's often the case. There's some data, you need some quick algorithms to get information about the data. Then it's exactly this, a lot of productivity gain. However, in these situations where there's a big software system that need to be incrementally involved, productivity gain is still need to be proved. Let's say it like this. We observe that. We have the measurements for that. And I would like to give you a small glimpse into how we measure that and what our preliminary observations are there. We measure, by the way, I didn't talk about Seerene and how we do this, maybe in a nutshell shortly. Usually there's a big organization, business units, departments, or in the agile world, like agile solution trains, agile release trains, teams, and they work on large code bases. Many Git repositories nowadays, or ClearCase, or whatever, right? But a lot of code and people working on that. And what we do with Seerene is we connect down there to all these infrastructure tools in the software development world, like code versioning, ticket management system, code checkers, everything what's already there, and make use of that data. And because we listen in many places of these very specific tools and repositories, we can observe the process, how activity is being done along this software development cycle. Disclaimer, we do this fully anonymized, otherwise it's been, in Germany at least, a workers' council topic. So we have also solved that. And that's how we can take the data and derive information about how efficient is the use of developer time in this department, in this team, in this code component. We can, about quality, time to delivery, technical depth, all these things we can quantify and observe in very complex, heterogeneous, large organizations. Just one example, what we can measure, how is developer time being used? Like if you have 100 developers, it's a lot of money you give as salaries, and a lot of this time of developers hits into code, which is very difficult to understand. Like if else, if nested structures, ugly for every developer in every programming language. And we can measure this because we can see our platform sees the code and we see where the developer time hits into these ugly areas. So we can express this as loss of time, or how much time of developer is being used just for fighting back defects, which is usually a large portion. How much of developer time is without doing something, without specifying first, without a ticket, without an issue. And usual number, actually, the number is typically even lower. Only 20–30% is left for creating business value. Right? So there's a lot of potential in nearly every software development organization. And this is one thing we measure constantly across the organizations. Second thing is we can even drill that down into the code architecture to see, for example, this is, we use the city metaphor here to visualize large code, grown code languages, code landscapes. And these building blocks are code units. And then we, for example, here, we can project where developer time gets stuck in which area, so it becomes very actionable for the teams to do some more test automation around these parts, or to break them up, refactorings, etc. So this is how Seerene Analytics works. And now I want to give you some preliminary observations that we see in terms of what happens if developers start using this screwing robot. And this is a typical curve. It's a real curve. And typical. So before, the amount of logic statements being produced per developer per week. So we measure independently if this is 100 developers doing the work or 5. So we normalize about the development input power and observe, for example, here roughly like seven if statements, if you will, like logic statements in the code. Are being 7 are being in this team are being introduced in the code base, and after switching to this screwdriver, this robot, it jumped up. So yes, we see that there's an effect of speeding up code production, a drastic effect, which is 2 or 3 times higher. And now comes the pitfall. Maybe you remember. This building here, if this speeds up, you need to be, you must be able to handle this speed, this amount of this pressure that comes from left to right. And what we then also see is not only that the production speed, the amount of code being produced speeds up, we also see a little bit time delayed that the effort for defect fixing pumps up, usually a factor of 2 initially, because it's like the tsunami wave. Like there's no handling this, and yeah, this is one of the effects, which means you need, if you take these Gen AI-based tools in your hands, you need to be aware that at the same time you equally must invest into quality assurance and test automation and smarter code reviewing processes. The second thing that we measure is, I talked about complex code where developers cannot easily change this because of if. GitHub Copilot and these tools work like I'm here in this if, and then I ask them, okay, now I have this data structure, and you write it as a comment inline in the code, and you write a comment, I want to iterate over this data structure and get internally all the person names in it. What happens is ChatGPT, GitHub Copilot produces a code snippet, which is, again, 3 nested ifs, or loops, for loops, which are sitting inside of these if, and now it goes further on, if, else, if. So it makes, today, the trend of these tools means that we call it a complexity pollution, the amount of code lines which are ugly because they are sitting very nested, this drastically goes up. It speeds up code pollution. It speeds up running into these maintainability problems that you have. Because in the foreseeing future, you still need the people that they can understand the code, right? So software code, maybe in 5 years or 10 years, that's different when these large language models can also consume entire software systems. But in the foreseeable future, code should be maintainable, kept maintainable. And what what you here see is code pollution ramps up. Here's some attempt to bring it down again, but right, you need to be very systematic observing that to use the harvest, the productivity boost, what you can reach with that kind of tools. But at the same time, you need to observe across your entire organization where the teams already use these tools in the right way to not run into these risky parts. So this is also our recommendation. Definitely provide, if you are responsible for the development organization, give these tools to the developers, because there is this productivity gain, right? But at the same time, introduce some measurements and some governance, some aligned autonomy, if you want to call it, because it's necessary to measure where these tools produce too much risk. And then, as a management role, right, you need to give some upskilling, right? Some help these teams to use these tools in a better way. So if you like, right, so we are starting now to build up these kind of benchmarks. So if you're interested, you could join. If you have a development organization yourself, if you're responsible for that. And also to see how, for example, how much of your developer power as of today goes into these inefficiencies, and all the money is burned and not used for business value add creation. So feel free to contact me, and thank you.
Thank you very much, Dr. Johannes Bohnet.